We're going to start with the design process. Remember, guys, this is the kind of stuff that I'm going to quiz you on when you have your quizzes, okay? Well, take a look at the top of the board. There it is. So, first of all, a process is something with multiple steps, as you know, right? So if you said that, like, I need to, I don't know, get a glass of water. The process would be walk to the sink, turn the lever on, wait, let the water fill up, turn the lever off, or turn the faucet off, and then walk back and whatever you want to drink. There's a process involved, the steps that are taken. So we're going to think about the major steps that are included or that are useful when it comes to designing something, specifically in engineering. Obviously, you go through many processes all the time and different designs for different applications, but this one is specifically for engineering, all right? So, by the way, I'm on from pages 40 to 46 in your book. This is what you were reading about. So the first step that your book recognizes, looking for the need for a product. The need for a product. So give me an example in the last 10 years where a product has come out as a result of a necessity that humankind needed. Give me an example of something in that sense.
The faucet.
A faucet, what do you mean?
Like you need to have water.
Oh, okay.
The last 10 years?
Yeah, the last 10 years.
iPhone
Sorry.
cases.
Like something new that's come out or recently.
Electric cars. They have like
Phil.
those things that can filter dirty water.
Okay.
A bottle.
Yeah. That's a great example. Something that filters dirty water. So for maybe third world countries or places where there isn't fresh water running, right? What's something else? I'm trying to think of something we can analyze. That's why that would be tough.
iPhone.
Electric cars really kind of appeared in the last 10 years.
All right. So
Commercially vehicles also.
let's go with that. I think that's a good one because we can talk about all these steps. So let's use electric cars the whole time. You have another example?
Solar panels.
Solar panels, and that goes along the idea of renewable energy. So let's go through all these steps for the design process for an electric car. All right, let's keep this as our idea in the back of our mind. So again, step one in the design process is recognizing a need, okay, a need for a product. Okay, we're recognizing the need for a product or service. And as James mentioned already, why is there a need for electric cars? Nick?
It's like there's like less and less oil, and also like it's like more like independent from like oil-producing countries.
Yeah, we really don't want to depend on countries that have all the oil in the world. So as, specifically for like the US and for Europe, electric cars could be a big thing. Okay, obviously it's also for renewable resources. We know with certain resources we're running out of them. Now, the caveat to that is that an electric car, you have to charge, right? So you're still using a resource in a sense, but the goal is to be able to get a more efficient product, right? Something that doesn't run on gas, that might not be as efficient for that instance. Now, before we get into the other parts, what are some setbacks that you automatically think about for electric cars? What's something off the top of your head?
Fire.
What is it?
Fire.
Okay, so safety. A fire happening. Safety. What?
Weight.
The
weight of the batteries.
weight of the battery, the actual weight of the battery itself. Yeah, it's going to be much heavier than the gasoline would weigh.
Well, how efficient it could be.
How efficient it actually could be.
Like if you charge the car, you need to burn coal to actually create energy to charge the car.
So there's still a carbon footprint when you're charging it. What else? There's other stuff I can think of off the top of my head right away. If you're driving and think about what would be effective.
Lithium-ion batteries don't perform very well with cold.
Okay, so temperature conditions are going to change the performance as opposed to gas. Once the car warms up, your car's running fine.
If you are going on a long distance trip, you can't charge it halfway through.
Yeah, first of all, there's not enough places to charge it right now. Second of all, you won't go as far.
Solar panels.
What does a full charge get on an electric car now? How many miles does it actually get?
Tesla is 260.
260.
Is that what they're claiming right now? Has Tesla actually been released yet, though, for sale?
Yeah.
Why did I think they were still in? So they do have a car that's out there. No, I thought that they were still in the development stage.
No, they're launching affordable cars now.
Okay.
Yeah.
So in the past, it was not affordable. We'll talk about
Yeah,
that.
it's like 80,000.
Okay. So how far are you going to go on that one charge? Okay, how far could you actually travel? All right, good. Second step, okay, is defining the problem and understanding.
that noise?
Problem definition and understanding. Okay, which is kind of what we were doing in a part just now. So we're defining why there's a need for it and understanding what we can do as a result, how we can actually make something that is sufficient to fill that need. The base isn't always, just keep an eye on it. Okay? It is, but it's acting up a little bit, it looks like, so just keep an eye. So understanding what the problem is, okay, and how you're going to treat it. If you don't understand what your client wants, so you have to think from an engineering perspective, all right? Engineers do things for clients. That's the whole idea. So somebody comes to you and says, you know, here's what I'm going to need, or this is the problem. If you don't understand what the problem itself is, you can't do anything. Ev, what were you saying? Sorry.
You don't want it to be ugly. It has to
So you don't want it to be ugly. Great. So yeah, if a client comes and says they want something to be designed that's aesthetically pleasing, well then you have to make sure that although it may function, it looks like crap. You got to make it look better, right? So you have to actually improve that.
And you might have to work with outside people when you're doing that. Like, so like GM just made a new Corvette, and when they were doing that, they had to have, you know, people doing exterior design had to collaborate with the engineers who were saying, we need a vent here, and it needs to be this big.
And they're like, well, we want this design here.
Yeah,
So you find that compromise, right?
Is that
So
what it's
yeah, you're constantly doing this, and it's true. So although you might understand the problem itself, the problem may give you some limitations, right? Or constraints. Remember the term constraints we used?
money.
Okay. Step 3 is research. Okay, research and preparation, but mainly research. Okay, if you do the right amount of research, you're going to have a good result. Now, why might you want to do research? Give me some reasons. Some simple ones. Dylan.
Learn more about the topic.
All right, to learn more about the topic. So maybe you're an engineer, but you're not an engineer specialist in that area, but you're designing something.
For efficiency, to make sure you don't like make mistakes that people have already made.
Very good. You don't reinvent the wheel. So when things are made and they're mistakes, why would you make the same mistake again, right? James?
like, if whatever you're designing, there's almost definitely at least one firm that just does that. So you can look at what they do and try to see like what the purpose of the thing.
Yeah, what worked and what didn't work for it. F?
How to fix a problem you run into.
How to what?
Fix a problem that you run into.
So if you have a problem, you might want to research that problem, yeah. So you might not know how to fix it, so you research it at first. Scott?
Actually, to see if like the data or like the experiments you need are actually out there. Because
Okay.
maybe it's like in the future and you just really have a good imagination.
Yeah, so see if something, again, exists already, or there have been some testing at least in that phase. So maybe the product doesn't exist, but as Scott's mentioning, well, maybe they tested already and they realized it wasn't feasible. So you figure out what those infeasibilities are? Is that a word? Infeasibility? James?
Let's just say that.
Infeasibility?
Feasibility?
Is that a word?
Yeah.
Infeasibility?
Not,
No.
you could say lack of feasibility.
Okay, so yeah, you can figure out what if there's a lack of feasibility for that idea. Okay. Well, James got 800 on his verbal SAT, so I always quiz him.
Really? Wait.
He did.
What?
Hey.
You got 800 on the.
All right, step 4. Step 4, conceptualize. What does the word conceptualize mean?
To like have the idea.
Yeah, it's pretty much come up with ideas. Exactly. Come up with a concept. So when you conceptualize, are you limited?
No.
No, that's the whole idea of conceptualizing. You use your brain, use your imagination. You think about what it possibly could be. And you don't come up with just one possibility, you come up with several. And then maybe you have a focus group. Maybe you have people that you're going to ask, which of the following is more aesthetically pleasing to you? And you present like 4 or 5 different prototypes of that. So along the way, while you're conceptualizing, you're also getting feedback from others. Maybe the others are the clients. Maybe they're consumers. Maybe it's your boss. Maybe your boss is just really power happy and he loves to control everything. He says, or she, and says, you know what? I need to see everything you do along the way. I want to approve every single step. That would be a terrible boss. You want a boss who would delegate, that would trust you in your expertise.
And this is also, I think, a phase where you, like in training system conceptualization, you need to also think like how versatile thing needs to be. Because again, with the Corvette, they're making a transmission for it because none of the existing dual clutch transmissions would fit in it. and they're making a new transmission, and they realized they needed to make conventional automatic instead of dual clutch because it needed to work in trucks too, because GM needed a new transmission for a lot of vehicles. So they needed to make something that would work in a Corvette and a Silverado, which was like too fast.
I was gonna say, those are like opposite ends of the spectrum.
Exactly.
So, yeah, the idea that you have to think about what the concept is being applied to. If it's applied to multiple things, you need to consider that fact. That's good. All right, step 5 is synthesis.
Photosynthesis. That was engineering.
When you synthesize, what does it mean? What are you going to be doing?
Testing.
You're gonna be like choosing, I don't know, like choosing an idea and sticking with it.
Okay, so you conceptualize, so you pick something, but more specific than that. More specific.
You're basically bringing your conceptualization phase like together into one like cohesive like idea that you want to pursue. You're bringing together all your.
It's like when you get more realistic and you're like, this material and blah, blah, blah.
Yeah, so that's the other key point. You have to think like, you you come up with the idea, you've decided on it, but now when the process of synthesis or this step has to do with, okay, what is the dimension going to be? What is the length of this? What is the material? Why is it going to be that? I'm going to start calculating at this point. Okay, so you begin a lot of those different calculations. Step 6 is evaluation. We all know what the word evaluate means, right? Evaluate. So what do you think the step of evaluation has to do with? The evaluation.
So like choosing the best path.
Yeah, now be careful because the next step is going to be optimizations. I think you want to push that to that. Just evaluation though. Evaluation is a little more than synthesis. It's the sense that you need to actually come up with the results. So, is this object going to fail under this amount of stress? Is the object going to move when it should be stationary? So you're coming up with an actual result. You're evaluating the actual product itself. Now, Scott alluded to the next step by saying you're trying to find the best path. And the next step is optimization. So in evaluation, you say to yourself, did I meet the need of the consumer or my client? But in optimization, what do you say?
How do I make it?
Yeah, is this the cheapest it could be? Is it the best it could be? Is it the strongest and at the same time the cheapest? Can I get the ratio of strength to cost to go extremely up? That's your goal always,
This is
right?
a business model. Like literally.
It's absolutely very similar. Yeah, of course.
Wait, what?
So when you're considering engineering, you have to consider things like budgetary stuff. So optimization is again not just not monetary only, but you might look at the structure. So is this the best structure for that? Could I change it so that I use less material or that it's aesthetically pleasing, but you still get the end result out of it?
If you want to not optimize it too much, because if you do, you're like, I don't know.
Well, here's the idea of optimization. In a perfect world, you want to make the best product, obviously, right?
Yeah.
But in the world we live in, when we can take this on, if anybody's a Mac consumer or an Apple consumer, everybody knows Apple is known for this. They have ideas 10 years ahead of what they want to do with their iPad, but they don't present them on purpose. What do? And then what do?
TCU raise the price.
Yeah, every year they come out with a new model with like 3 new features, and suddenly it's $500, and everybody gets ripped off because a year later that same model is going to be only $100. But because everybody wants to get it when it comes out, they pay $400 or $500. So yeah, if you over-optimize, if you come up with the best solution the first time, you might knock yourself out of the market. Okay, you might knock yourself out of the market for that item. Now, at the same time, maybe this is a product that you want to make once and that's it. It's not something you're going to have multiple generations of. For example, like something like a screw. Like an actual screw that you're going to use to, hardware. You're going to screw something into the wall. They haven't been changed much in a long time. Okay, screws themselves actually were optimized a long time ago. The actual the coarseness of the threads, the direction the threads were in, all this was studied and researched, and they came up with the optimal solution. Nothing has changed really since then. And if you research this a little bit, you can read about this. That's an example of one. I was actually reading on an article randomly because I was trying to figure out why threads go one way or the other. And it went into detail about how screws and bolts and everything like that and hardware in general for a long time now has not changed. Nothing about it has changed. So maybe you're creating a product that needs to happen once and is not going to be multiple generations, and in that sense, you'd want to make the best product possible. But like MakerBot is a perfect example of what we said a moment ago, right? MakerBot, they're coming out with different models. So they're not going to come out with their best thing right away. Maybe, for them, they don't know what their best thing is right now. So they can improve over time. And that's the key with optimization. Optimization is not always instantaneous. There's always a time interval that's involved. Whether it's like 2 months, so you come up with the product, you evaluate it, and then your boss says, all right, I'm going to give you 3 months to cut down the cost by 30% and increase the structural strength by 20%. So now you have a time limit to complete that optimization. But that doesn't mean that once you come out with a product, that next year you can't change it. Okay, so optimization is an ongoing process. Although you're looking for the best solution, you can constantly improve that solution. That make sense?
Yes.
Okay, optimization. And traditionally, words you're going to hear in optimization is minimization and maximization. You maximize maybe profit, or you minimize cost, or you minimize material, or you maximize strength. Okay, so it'll be useful to know those words. Keep them in the back of your mind. The final step, step 8, is presentation. And that's kind of self-explanatory, but what do I mean by presentation? Being able to do what?
To sell it, to use
To
it.
sell it, exactly. To use it, to present it in general, without using the word presentation, right? To give some sort of an explanation. If you can make something that's amazing, but you can't sell it to somebody that's going to buy it, you can't explain how it works, they're probably not going to buy it. Has anybody ever seen The Pursuit of Happiness
Yes.
Yes.
with Will Smith? All right.
Jaden, right?
With Will Smith and his son, yeah, and Jaden Smith also. But with Will Smith, remember he's trying to sell in the beginning of the movie? Those bone density scanners? They're bone density scanners? Well, in the movie at the time, there wasn't things like, I don't think there was stuff where you can get like MRIs and CAT scans. It took place in like the 80s or 70s. That's when the movie itself took place. So there was a need for the product, but in the beginning, he wasn't always the best salesman. He wasn't always good at pitching exactly why they needed and how it worked. So if you can't present something, it's not going to do any good. You could build the best product ever, but if you can't actually explain to somebody what you're building and why you're building it and the need for it, it's not going to be useful to everyday life. Okay, so that's the last step, which is presentation. So let's take a look, and let's think about the steps it would take for an electric car for these. Okay, for an electric car. So the need for it we talked about the definition. Research. When it comes to electric car, what might you do? What might you do to research electric cars? How would you figure out if something's been done? You can't just Google stuff, right? It's like, let me Google and see what it is. You can see what's been made, but how might you go into research?
You see the market of other electric cars that are out there.
Okay.
Dissect those cars.
All right.
See what they're doing.
So that's called reverse engineering. That's one way. Reverse engineering is taking something apart that's already been made.
Or maybe get funded by a university and make sure everything's legal.
Yeah, do your research with the university, and at the same time, then you can also look at papers that have been published on that topic. So a lot of research comes to actual journal articles. So, like, for example, the American Society of Mechanical Engineers, ASME, has their own publication that comes out monthly with articles in it. 2 of my professors at Villanova were in there all the time. They were constantly inventing different things. They were always coming up with research papers. So people publish themselves, so that's a good place to look. It's not open to everybody, though. You can't just Google ASME publications. You need to join ASME or get a subscription to it and then do some research behind that.
Are you a member?
I was when I was in college for 2 years, for junior and senior years.
What if it's something that is actually like there is no research on it? There's no.
Well, then you have to start from the beginning,
You're
yeah.
obviously really smart, but.
There's definitely stuff that doesn't have anything with it. Maybe you came up with a brand new idea, well then you find that there's no research. So you do research to
Yeah.
figure out that there's nothing there.
But I mean, what would you turn to? You just.
You go
I
to
mean, you would
university.
Well, then you start making models on computers,
Yeah.
simulations, but there's nothing that you can see for data that's out there.
Yeah.
Sometimes research doesn't help. Again, research is there to check. It's really a check. It's a safety. It's saying, does this exist already? Has this been done? Do I have to reinvent this? Can I improve this?
Plus, if you're looking at something as complex as an electric car, there's going to be a bunch of parts in it. So you can research what's been done with the parts, like where battery technology is at.
Absolutely. Keep talking.
where like, you know, like how a car's weight balance would change if you ripped out all the internal combustion components. Like, there's still stuff you can find out even if no one's made it yet.
Okay, so that's for that. Conceptualize and synthesis for this. Conceptualize. You might have to come up with an idea of how you're going to have that energy transferred to the actual transmission or the actual axis when it comes to an electric car. You certainly don't have combustion. You don't have pistons moving up and down every second that's moving. James, do you know anything more about electric cars and how they actually run?
How they run?
Because you were telling me about the article you read. I don't know much about electric cars.
I mean, I don't know a whole lot. They just, you know.
The energy you use powers what though?
Oh, it powers electric motors that are actually at the wheels themselves.
Okay. So there's definitely no cylinders, any of that at all,
No,
right?
there's not even a transmission, I don't think.
Okay. So you're pretty much using energy to power some sort of a rotational axis. And we call that an axle, but it's an axis meaning it's a cross. Okay, so you have a motor on each end that turns it, but the idea is that you literally have to find that connection between the electrical source and the actual mechanical motion of the car. Evaluating, what might you do to evaluate?
Test drive.
Test drive, yeah, okay? You would use test drive. So you might have some sort of a facility where you're test driving. James?
And you can also, like a place like the US is handy for this because we have so many different climates. You know, you test it in Alaska and you can test it in Death Valley and you can get those like extremes of temperature and pressure and whatnot.
Yep, you have to look at your conditions. You have to think about the fact that if you want a product that's going to be worldwide that might be sold for any country, you have to think about the fact that it could undergo different circumstances. Guys, focus, come on. Focus. Optimization. Optimization in an electric car, what would you try to optimize? Give me some parameters.
I guess like the battery is small as possible.
Okay, battery as small as possible too.
Charging time, short.
Increase, charging time, decrease, charging time, yes.
You know, increase the total capacity of the batteries while still keeping that other factor in mind.
Increase battery life or the capacity, the actual amount of joules or energy that it can hold.
Increase the distance the car can take you.
Increase what?
The distance.
Yeah, so a longer run. So you make it so it's more efficient so you can go further on the same charge. The weight. Okay, you might want to minimize the weight. Alright, so that's for optimization. And then presentation, you have to present this to somebody. You might present this with data. Okay, you probably wouldn't present this. You might present the object, but you're not going to have like panelists watching you drive the car right there. Maybe that would be closer to actual manufacturing point where people are watching. But in the beginning, you have data charts. You have graphs that show, okay, take a look. As a function of temperature, this is what happens to battery life. As temperature increases, battery life decreases or increases, or whatever it is. And then you come up with some general trends and results. Okay, you need to make conclusions based on your evidence. And those conclusions are what you're going to present. Now, the other part that people forget about is when you present, it's also written. A lot of engineering is writing also. And you have to kind of get to that understanding because honestly, I was not a big writer myself when I was in high school. I was more into math and science, and that was one of the reasons I went to engineering. But when you actually build or make a product, you need to write about it. You need to actually write a report. You need to go through all the steps that came about. You need to talk about why certain things worked and why they didn't, and why you chose certain things over others. So although you're going to present this in a formal presentation, like orally, you also need to present it in a written form. Okay, so for example, when I was in college, we had what was called the capstone project. And in my senior year, our project, we decided we made a abdominal workout machine for someone who's in rehab for like a back injury. So imagine you were like doing crunches, right? And you're trying to strengthen your stomach after you went through some sort of a surgery. The reason we got this, my brother went through surgery. He had a hernia? Is that not a hernia? What is it called? No, when it...
Hernia.
Is it a hernia?
It's when it comes out of place.
Not appendicitis. When something collapses to your stomach lining. It's not a hernia, I don't think, is it? What is it? An ulcer, I think. He had something with his stomach lining. And he had to get like a small surgery. It was probably an ulcer then, yeah, I don't know. But he had to get surgery. And as a result, the doctor goes, you can never do sit-ups again. Like he told him, you can't do ab workouts anymore. Or else this could happen. It could rupture again. So he was like, I can never do ab workouts again. That doesn't make sense. You should be able to at least go to rehab and train yourself. He's like, well, if you want to be safe and you don't want to hurt it, don't do it. So, as a result, if you can't ever do an ab workout again, you're going to end up with this big stomach over time. You guys don't know it now, but I promise you will if you don't ever work out. I speak for myself. So, the idea for the project that we came about was we saw a need for it first, right? A necessity. And then we said, well, let's take existing products. So you know what we did? Remember the thing that was on TV for a long time called an ab roller?
Yeah.
And it was like this thing, it was like this little metal frame, and you kind of like rolled up like this, and you put your arms on it, and you had weights. We didn't make it, it was on TV already. We researched and found that object existed already. Then what we did was this. We attached a vertical bar, so you're laying down. Okay, I'm laying down right now, I'm doing this ab workout. So here's the ground. We attached vertical bars coming out of the ground. Okay, we built a frame around it. And on those bars, we used springs. So when you went down, part of the force to lift you up was the springs themselves. It was an assisted. We called it the assisted rehabilitative abdominal mechanism. It was called like ABAM or something. It was some stupid name, ARAM or something. I don't know. So we built a prototype. We didn't actually build the whole. We designed it all in CAD. We used SolidWorks to discuss the stress on it, if the beams would bend and stuff. And then we just built a prototype for it. We used wood. It wasn't anything fancy. Not really. It's if you have an injury and you can't do a sit-up. So the idea is this. You lay back on it, and as you lay back, the springs would stretch. Remember in physics you learned about potential energy in springs? I taught that today, actually. Got a weird time, right? So you lean back, and obviously you can lift yourself up, but the spring has a certain amount of force. And if we made them so that they were interchangeable springs, so that the K value could change. The K value on the spring indicated how strong the spring was, if you remember. So a stronger K value, it would not go as far back, it would pull you up much easier. So we had interchangeable springs. Then, after going through the synthesis and the evaluation and optimization, we then realized that, the design process is a cycle. Sometimes you have to go back to the beginning. And a professor of mine suggested something that was a great idea. And he said, well, why don't you make it so that there's hydraulic actuators instead? And a hydraulic actuator is like, imagine, have you ever seen the dampers on doors when you let the door shut and you see there's a little cylinder up here and it slows down? What's happening in that is there's a disc. Is it what?
Viscous fluid.
There's a disc that moves through a viscous fluid, and that disc pushes over the surface. And the disc feels a viscous force, like your hand underwater. So he said you should use hydraulics that would help you lift or lower, and you could change it with a digital scale. Instead of interchanging the springs, you could change the amount of, say, pressure that's in the hydraulic mechanism so that it assists you more or less as a result. So that was more of a modification of the original design. So we didn't actually do that, but that was the feedback that we got. So we presented it to a panelist of engineering professors. We presented it to our peers, our students were in the audience. And then when they discussed it afterward, they gave some feedback. And this was when I was in grad school that my advisor presented that idea to me. We never followed through with it, to be honest. The two people I worked with were out of school, and I was busy with school and stuff. So we never ended up building anything else. But the idea that you want to modify and go back and change things. Okay, that it's a cycle. So, now, with that said, here's what I want you to do for the next week. It might take you a week, it might take you a little more. I'm hoping it'll only be like a week project. I want you to use the design process to do the following. And I'm going to give you groups, okay? So for this one, I'm going to specify your groups. It's going to be 3 groups of 3 and 1 group of 2. So it'll be 4 groups. It's going to be a competition, okay? So at the end, we're going to test this. So your goal is to do this. And it's going to be using CAD, and it's going to be using the design process, all right? So I want you to design and print, again using CAD, design and print a pine wood boxcar derby car. So if you don't know what those are, if you're ever in the Boy Scouts, you would be given a block of wood, and you'd have to shave the block of wood, and you'd have to come up with the contour that would have the least resistance, that would be the best for any drag on the car, and then you'd have to weight it down. And you had to limit the weight that it could be. And you'd have to figure out where should the weight be located. Should the weight be along the bottom? Should you put metal strips? Some people put these metal cylinders inside of it. They drill a hole, put the metal cylinders in, and put wood cutting on. But the idea from that is that you're given a block and you're shading it down. I want you to create this in CAD. Now, it seems a little difficult at first, but it's not that difficult. I've already got axes, or axles rather, and wheels for you. So you're only making the body. And then once you make the body of it, okay, the body, everything, just put holes through it for where the axle will go through. But your goal is to design the body in such a way that it minimizes the air resistance so that it can complete the race the fastest time. So I bought a bunch of track for this, a bunch of tracking and things that we're going to set up in the gym. And then we have some timers, some sensors that will time the race. So what I want you to do is to work with your group members on this idea and come up with possibilities. Then start designing in CAD. Maybe one person can design one part, maybe another can design another, and you put it together. Or maybe you're making one solid object that you can use. Now, keeping in mind that if you want weights attached to it, you want to put weights, you have to put weights inside of the vest. So that would involve making something that has a rectangular prismatic hole in it. You follow what I'm saying? So put a plane inside of the car and then make an extrusion that cuts instead of builds. And you cut a little rectangular hole. So as you're printing it, right, you're printing, you know at the point where it's still going to be open. You're going to see this little open rectangle in there. You can drop the weights in and then let it print and finish. So you can literally print around the weighted masses. But that needs to be like your final design, or you have to be able to break it apart to get the weights back out. So each group is going to get a set of weights. I just ordered them the other day. It should be in by like Thursday. Okay, you'll get a set of weights, and you have to use those weights accordingly. I'm not going to tell you how you want to do it, but those are all the weights you can use. You can't add any more weights to it. So if you want to space them out, certain in different orientation, if you want to use some and not others. Okay, but your goal, your overall goal, is to complete the race in the fastest time. Okay, that's going to be your goal in the process. There's not really much besides material properties, but you're going to have some geometric constraints, like the tracking itself, which I'm going to give you.
Is the track flat is it straight?
It's sloped down. You don't need any power to it. Use gravity. It's all gravitational energy. So it is straight and it's sloped down. The angle, I don't know what it is right now, but I'll give you more of those specs. Today I'm just going to have you start developing ideas with your group.
Can we have nitrous?
No power at all besides gravity. It's all gravitation. Yeah, because then you could also have like a spring-loaded car and stuff. What was your real question?
Yeah, you should have sold the ARAM, whatever thing. You could have been a millionaire now.
I didn't think it was that good of a design. It would have to been a lot more work to do on it. Maybe something like Shark Tank would have been good on it. You gonna say that? Yeah. Because they can improve stuff if you sell it to them, they'll improve it still. So, the idea. Feel free if somebody wants to run with it. You can make that idea. I can copyright it, so obviously. Does it make sense what you're going to be doing? Alright?
Yeah.
I'm going to give you your groups now.
Okay.
You ready?
No.
I'm ready.
Are you sure?
If I don't like my group.
Alright, ready guys?
Whoa, that's me.
Wow.
Teresa's not here, so I have to give her
Which one
hers.
of the people in the grade you don't like? Let's see who's lucky enough to be in my group.
Absolutely no way.
I'm going to come with the groups right now.
Let's see
He's gonna make them up right now.
Whatever you do, just don't put me with malaria. It's lazy.
Stop it.
Yeah,
I got that one hilarious.
Yeah, Joe, I would not, I mean, not that you're lazy, but you're not always here, so don't give him a hard time.
Oh, I know that.
I'm just saying, you know.